Can you hear me?
Yeah, can you hear me?
I can't hear you.
Hold on 1 second. Is it better now? Can you hear me?
I wonder if I need to call your phone number.
Okay.
Can you see my screen though?
I can see your screen, yes.
Can you nod if you can see it? Because I can't hear you. Okay, good. Because I was using my webcam and then it was like backwards. So I couldn't figure out how to.
One second.
Okay.
Can you hear me now?
Go say something again.
Now? Can you hear me now?
I can hear you. Yeah. Okay.
Great.
All right.
Okay, so let's do this.
So you can see my homework.
Yes, I can.
Awesome. Okay, good. I wanted to do the screen sharing then. Okay.
Okay,
Awesome.
perfect.
Yeah.
Okay, this is awesome. This is great. Okay, so let's see here. So for this is the homework that you're looking at right now, right? This is the homework we're going to be working on together.
Yes.
Perfect. Okay. Let's see. Find the area of the shaded region. The graph to the right depicts IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15, so 85 or 115. Click to view page 1 of the table. Click to view page 2 of the table. Okay, so what was difficult about this? Because it says you get 8 out of 20 points, so 40%. Is that the entire thing, or is that just thus far?
That's this far. So like all of the questions, that's what I have so far.
Oh, cool. Awesome.
So
Okay.
I just haven't finished this one.
Okay, so the good thing here, the great thing here is this. We have unlimited opportunities to get this right. That's what we care about.
Right.
Okay, so what for you is difficult about this? Let's talk about that.
Just understanding what's going on. I haven't really looked at it.
Okay, so
we're okay.
Let's look. Yeah, okay. We can go over any questions that you want. So let's first look at this and figure out, okay, how does this make sense to you? How does it not, or why does it not make sense to you?
Okay. I mean, I know when they have tables in here that I probably should refer to them, and this is probably the same as the chart that I have out of the book.
Okay, perfect. Okay, so all right, so let's look at this here. So first, let's work through the problems. Tell me, what I like to do is, what do you think the answer is? And if it's wrong, we'll discuss that. But if it's right, we can also say, why is the answer right?
Okay.
So let's talk about this. What do you think the answer is right here? And whether it's right or wrong, what do you think?
Well, I don't even know where to begin, honestly.
Okay, so
I don't know why the in-between region throws me off. I was using the calculator in StatCrunch.
okay.
And so if I open this up, it gives me not graph. Stat, calculator, and the first few problems had to do with the normal.
Okay, so let's see. Mean is 0, standard. So let's put the mean as 100 and the standard deviation is 15.
I think that's what I tried to do. 15.
Okay, let's compute it out.
About 0, but so there's no shaded region between here. And I don't know about this number.
I think there's an error there. Okay, so now what's weird is because I can't really. If you look, okay, there's a hash mark. Can you see my mouse or not?
I wonder if I can give you control.
Let me see here. Control room, Q&A, showcase, screen share. Let's try that. Application window. There we go. Blank out right there. Okay, can you see my mouse now?
Yeah, it's pretty tiny. Let me see. Where is it? Are you on the same screen as me or no?
Yeah, I am. Can you see it or not?
I can't see your mouse. No.
Dang. Okay.
I know.
Let me end the screen share then.
I don't see if I can give you control.
Let's try it now. How about now?
Yeah. Okay. Let me. Yes. Okay.
Perfect. Okay, so you can see my mouse right. Okay, so if you look, so it should be. So I'm thinking like, if you think about it, it should be what? Standard deviation should be like 85. It's probably right around here. Shaded region should be 115. Should be right around here. Okay, so let's go back to the problem.
Okay.
So let's go back to that original problem. All right, so the area of the shaded region is negative. Now, is that the number that you figured out?
Well, I was plugging it into the calculator, so I'm haphazardly doing it because I don't know.
Okay, so let's figure something out here. So the area of the shaded region. So let's look at something here. Let me pull it up. And 1 second here.
Okay.
So traditionally, with the area of the shaded region, you would take like one standard deviation minus the other standard deviation and divide it. So let's see, area of shaded region, then stats. Okay.
There's another thing we can do, Ross, is there's help me solve this.
Okay, see, perfect. You kind of get like a lifeline here.
Yeah.
Okay. So let's look.
The reason why I try to avoid these is because there's 10 parts. You have to do all that, and then on top of the question, and I don't know. I don't know what my strategy is here, but
so let's talk about figuring out a strategy. So let's see. Find the area of the shaded region. The graph to the right. Blah blah blah. Okay. While even techno.
It's going to use the current problem, and then once you go through this help me, it'll reset with just different numbers. It'll be off by like something else so that you have to work it.
Okay.
So it'll just go through exactly the numbers it gave us, but it'll reset once you try to attempt it again to some other numbers.
Okay, so that's it's weird. I wish to give you like a better sort of okay, so here's the thing. For the area of the shaded region, what's weird here, see, the fact that it's a negative is what's concerning. So let's go back to the homework.
Well, that's what I plugged in.
Okay. Why do you now? Why would you think it's a negative?
Because when I plugged in to the when I plugged it into the stat calculator I was showing you,
yeah,
I was trying to figure out the number, and I had come up with that. That was the last number I had entered. I didn't check it. I just had it in there.
So pretty much, I think we have the answer right in front of us. We're just maybe missing something. So let's see. So now it's a standard deviation of 50 with a mean of 100 and a standard deviation of 15. So let's see. Let me just plug in some. I've on my phone right here. I'm just trying to look up some stuff.
Okay.
100 deviation of 15. All right. So how would we do this? So okay, So here's how I would do it. Okay. So that's why I thought it was the fact that it was not going to be. It was going to be negative was concerning. So all right. So
sorry, that was me.
No. It's not a problem. So here's the thing. Like, what I like to do is I really like to understand it, and I like to see why things are a certain way. That's kind of think that methodically. So okay. So here's what I found. I did it in my head, and I just checked the answer. So the mean is 100 with a standard deviation of 15. The results come very close. Blah blah blah. Okay. So first you have to convert your scores to z-scores. That's what I did. A z-score is the number of standard deviation that a particular score lies above or below. So for your examples, the z-score is 115. 115 going up. The standard deviation is going up to 115. That would be people who, if you look at your graph right now at 105, that's like the higher end. 115 would be like the brilliant people, right?
Okay.
So you have 115 minus 100. 115 being the high end, standard deviation, 100 being the mean.
Did
And
you add
and
100 plus 15? You
yeah,
added the mean and the
yes,
standard deviation?
yes. So you go 100 plus 15 minus 100. And then you would divide that by 15 because 15 is the standard deviation. So in this case, for the z-score, z would equal 1. Let's see, 115 minus 100 divided by 15, so 15 divided by 15. Okay, so let's go here. Shaded region. Okay, so you then go. Okay, so for the shaded region there, that's okay. Okay, so I told you okay, that was the other way. Dang it. So the shaded region would be 75 to 105.
Uh-huh.
So let's go 105. Trying to think here what the best way to do this, because 75 and 105 play a part, and we're trying to figure out the IQs between 75 and 105, right? So what I would do is kind of like I would do 105 minus 75 divided by 30. Let's see what that is.
Where are you getting 30 at?
That's the difference between 75 and 105.
Oh, the different. Okay.
Yeah, so that's what I'm trying to. I gave you the wrong. I was doing it the other way from like the higher end. So 105 minus 75. Oops, I'm sorry. Say 105 minus 75 is 30. Divide that by 30. It would still equal 1.
Right.
So okay. So then here's what we would do then. Okay. Go to the table. Okay, so let's refer to the z table.
Okay.
So we refer to the z table,
I
and
don't think it's gonna be negative though.
yeah, I don't think it's going to be negative either, because the thing is like if it's asking what the like, I feel like the answer would have to be 1 if you're asking me further, but it's not on there, right? Okay, so if it's, let's say, 0.01, and there's no 1 there, right? There's no 1.0.
There's here on the
Oh, right
left.
there. So let's put that number in. 1, I'm sorry. Let's put this one right here and see if that comes up.
Where were you pointing? I'm sorry.
I'm sorry, it's the 1 point right there, and then it's 0.00.
Oh, the immediate number. Okay.
Yeah. So let's see if we can.
413.
Yeah.
Okay.
Let's see if that's correct, because if not, I think I have another solution.
0.8413.
Let's see. Dang. Okay. Sorry, that's not correct. Find the area under a curve.
Track the cumulative area. Converting the normal random variables to standard normal random variables.
Okay, that doesn't make sense. But the table.
And okay, use technologies here. So
Okay, so it's
x minus mean over standard deviation, 100 over 15. X minus 100 over 15 equals
okay. So let's think here. So let's find the area. These suggestions that they have are not very helpful.
I know. See, I read this. I'm like,
It's actually, I'm sorry, it's actually more confusing to read that. Like,
can we work through a help me solve this and just
sure.
see how it
Yeah.
walks step by step? That's how I've been kind of struggling through it. So let's see. So Okay, it's going to tell some of the same jargon. Okay, there's that.
Okay.
Thank you for that. And then it says, all right, so find the corresponding z-score
minus.
when x
Okay.
is 75.
Okay, so we just had it backwards. Okay, because the examples that I was looking at do it the other way.
Oh,
So,
okay.
okay, so let's look. Okay, so let's go 75 over 100 divided by 15.
Okay. And again, where are they getting the 15 from?
15 is the standard deviation.
Oh, it says that up here. Okay.
Yeah, so 15 is, so it's actually, that's actually negative 1.6.
Why aren't we dealing with the 105?
That's what threw me off because the examples that I was looking at would reflect the 105. See what I mean? It would
Yeah.
reflect the 105. So yes, that was the tricky part. So at this point, let's just stick with the 100 because when I was running through the numbers, yeah, so negative 1.66. Okay, so
Uh,
let's
decimal places, so 6, 7.
what's like 1 point, yeah, so it would be negative 1.67. Yeah, perfect.
Okay. Let me check that. All right. And then
Excellent.
continue. All right. So now
Okay.
we take 105.
Minus 100. Okay, so that makes sense. Okay, so basically the X factor is the 75 is the low end of 75 and the high end of 105. Now, so the 75, like on a bell curve, 75 would be the quote unquote the lower end, and 105 would be the higher end.
Mm-hmm.
So what it's saying here is 100 is like our basis. That's our mean. Most people people have an IQ 100, and 15 is that standard deviation.
Okay.
So let's see here. So one thing I want to suggest too is I know it's you and I both work full time. It's a real pain in the neck, but these are the types of problems we have to work through so you thoroughly understand.
Mm-hmm.
I know it's a pain. I know, but it's kind of like when you work out, like you have to kind of get through that beginning steps and then it becomes a lot easier, like boom, boom, boom.
Right.
But so here's the thing for that. So 70, so that one negative 1.67. That was with the 75. So let's do here 105 minus 100,
Uh-huh.
5 divided by 15, which would be 0.33.
It should be negative, right?
No, it's positive.
Oh, duh.
Yeah, so 5 divided by 15 would be negative would be 0.33.
Positive. 0.33.
Okay.
Okay. And therefore, the z-score corresponding to x equals 75, z equals negative 1.67. Okay, we got those answers.
Okay, perfect. Okay, so let's keep going.
Okay. The shaded region shown on the problem statement has the same area as the shaded region shown to the right. Shaded region in the graph to the right is the area between z equals negative 1.67 and z equal, okay. Standard normal distribution between 0, standard deviation of 1.
Okay, so see that? So so negative 0.67 to the left, that's the lower end of the bell curve, and
Mm-hmm.
0.33 to the right, that's the higher end of the bell curve. So that would be the amounts to those z amounts are as a result of the like actual numbers, not the fractions or decimals that were given us, but the actual numbers as a corresponding to z score.
Okay.
It's it don't ask z scores. Don't even ask me about why they exist because I have no freaking idea.
Yeah, I don't know how they created those, but
Who knows? All right, so let's look here. So let's go to okay, so begin with the z-score of 1.6 by locating 1.6 in the left column. Next, find the value of the adjoining row of probability settings that is directly below 0.07. Okay, so let's pull up the z.
I think it's going to be, well, that's a negative one, so we'll pull up this one. Okay,
Okay.
so
Okay.
1.6 here, and it says under 7.7.
Yeah, so point seven, 0.07, but it's a positive 0.07, not a negative 0.07.
Yeah, it says, I
Oh,
mean,
right there. Okay.
negative. I'm on
So,
the negative table.
oh, I didn't see that on top. I'm sorry.
It's on the left side, but is that right, or should it be positive?
No, so it would be
It's
um
negative because this is negative
yeah.
1.6.
So let's look corresponding. So let's go down. Let's go
And
down.
this,
So for the z-score of negative 0.16, keep going.
yeah,
Okay, so that would be boom right there, negative 0.16. And it's going now, let's go. It has to correspond to 0.07.
yeah, at the top here.
Yeah, at the top there. Perfect. So,
I'm
so
in that
let's
row.
perfect. Okay, so the answer is
0.0475.
yes. Okay, so 0.0475. Okay, so
Right. Let's see if that works. Oops. Okay. There's nothing to fill in there, but
okay.
0.0475.
Yes. Great. Okay.
Okay. The area to the left of the Z is 0.33. So we're going to use this side.
Yep. Perfect.
And sorry, what did it say? It said, do I still use, well, let's see. Okay. 0.33 on this side,
Yes.
but do I still use the 0.07 at the top?
Now, that's the part that was a little bit confusing. So let's do that. Let's do 0.33 and let's do the 0.07 at the top.
Okay, because I
So that,
wasn't sure where that number came from.
yeah,
Point,
that's the thing. There's not really a lot of rhyme or reason for that. That's the thing with statistics that's really frustrating.
okay, so
Is
0.9996. Let's just
okay.
see. I guess I don't need that. Okay, so there's some reason.
Okay, let's look here. So begin with a z-score of 0.06. Okay, find the value. Okay, so let's scroll down. 0.07. Okay, next case, standard deviation. Okay, so perfect. So let's find the value in the adjoining probability that's directly under 0.07. Okay, so perfect. Let's scroll down. And area to the left of Z is 0.33. Okay. Let's now, okay, let's just go back. Let's go back to the click to view page 2 of the table. 0.33. Let's put in 0.6179 because
0.33?
oh no, it's no, that's I
Oh,
think you're
that's
looking no,
0.3.
so you were looking at
Oh.
yeah.
Okay, I see what we did.
Yeah, so you were looking at 3.3. It's
Yeah.
0.03.
Okay,
Okay.
so we're going to do 0.6179.
Yeah. And if not, we'll look at 0.07. These Z tables are so confusing.
Okay, 0.6179. 6179. Hmm. 6293. Let's see what that was under.
Let's 293. Okay.
62.3 was under 0.03.
So 0.03 to zero point zero 0.03, it's consistent. Okay. So
Is it
that makes
because if you added 0.07 and 0.03?
well, it's pretty much saying here that if the number isn't given, if it's not like if like it would say look at point I think it's at 0.07 for one of those. If it's not given, now I'm starting to see the patterns again with the Z tables are a little bit different because
Mm-hmm.
Z tables are kind of annoying. So point
Yeah.
0.3, yeah, 0.3 to zero point 0.3 is it makes sense because the standard or the area would be consistent with how much the deviation moved in one capacity. So effectively here, let me just look at z-scores right now. We found like a really good definition of a z-score. Okay,
Okay.
or z-table, standard normal z-table, hypothesis testing. Okay, so the graph shows standard deviation, blah, 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 blah. Okay, so it's basically allows us to use percentages, right? So that's what the z-table is. It's
Okay.
corresponding percentages. So for 0.3 to 0.3, you you would go to 0.33, and then on top of that z table is you look at also at 0.33. It's consistent because they haven't given us any other additional information. You see what I mean? Like it was like, like, so you're at 0.33, it couldn't be 0.0 because it would have told us to look at 0.00.
Right.
That z score, the z score would have indicated it's 0.3. Now you have to look at 0.00 to correspond to figure out the percentages. That's all. What we're saying here is at 0.33, it's 62%. So 62% of people have the IQ of less than like 75. They have the IQ effectively 75 or less.
Oh,
Yeah. So it's, yeah. Yes. So it's going to be a little bit less. So, okay, so let's do the area. 0.6293 minus, let's see what that is.
0.6293 minus 0.0475. Okay, I have 0.5818.
Okay, so let's put that in there. So, okay, so, and then let's go check answer.
Okay. Okay.
Okay, so let's talk about this. Okay, so the difference
This was
between, yes, so, so
trying to
that's,
understand
so the difference
it.
between, yeah, so it's based on
Sorry,
percentage.
the 0.33 was the high end.
Yes.
Negative 1.67 is low.
Yeah, so what we're looking at here, so 0.623 is the high end. So let's say 62% minus 4% would be about 58%. That's the, and here's how I think about it. The people with the IQ between 75 and 105 it's 58%. So more than half of the people are within that shaded region. Does that kind of make sense?
Yeah.
Okay. So I 0.623, so 0.6293, which is that's the 0.33. That's the 105, the higher end. 0.0475. So it's like percentages. So it's 62% minus like
4%.
like 5%.
Yeah, 5%.
So 58% of the people have the IQ between 75 and 105. That's what the shaded region represents.
Okay.
Okay. Does that make sense?
Mm-hmm.
Cool.
It does once we've gone through it.
I'm sorry?
I said it does once we've gone through it.
So let's go to another problem.
I wonder if I can print. I'm just gonna see something really quick. If I can print these. No.
Here's the thing is it's a real, like I said, it's a pain, but what I want you to understand here is like it's all based on percentages. That's what probability is.
Mm-hmm.
What's the probability? Like most people don't watch baseball, but like talk about the Super Bowl. Like you look at like Tom Brady's like passing percentage, right?
Right.
Like look at the shaded region, and like let's say the shaded region of this passing percentage within 5 yards is like, between 5 and 15 yards is like 80%. But they're going to assign different z scores to the 5 yards and the 10 yards.
Right.
And then you figure out the percentages from there.
Okay.
So it's a little, like I said, it's a little bit.
So looking at this formula here, we solve for the z, or because this was the low end, we plugged that into x. Is that
Okay, so your z-score would equal 75.
because I'm looking at it as I'm plugging in the numbers. So
Yes,
this
exactly.
is, well, this is the mean. So we would put 100 here. So that makes sense. We put 100 here.
And I think it's the omega sign or the alpha sign. And then on the bottom is 15. That's the standard deviation.
All right, which is here. So they're giving us the numbers. So I'm trying to figure out where to put them when I go to solve this. And then this x is going to be either the low end score minus the mean or the high end score minus the mean. And we divide by the 15 on both of them. That's how we got these.
Yes, exactly.
Okay. Okay. So as long as I can start, I can.
Okay, so does that make sense?
Yeah.
Okay, cool.
Low score and high score. Okay.
So here's one thing about math. The answer's right there. The answer will be right in front of you.
I know. And then I make careless typos and get it wrong anyway.
Like I said,
Yeah.
we'll just make sure we slow down. And that's one thing I would suggest.
So, see, it just changes it slightly. So now we have 70 and 120.
Yes.
Okay, so let's try this. So z equals, we'll do low first. So z equals 70 minus the mean, which is 100, over the standard deviation of 15.
Yeah.
So we're going to go 70 minus 100. I should know that, but we're going to do it anyway. Negative 30 divided by 15 is negative 2.
Okay.
For the z, for 1z.
Yes.
1z. Okay. Then z equals the high end of 120 minus 100 divided by 15 equals 20 divided by 15. And that is z equals divided by 15, 1.33 repeating.
Okay.
Okay, so we have two z-scores now.
Yes.
All right, so then we went and that's why I wanted to print out that page because
Yes.
we don't quite go to the chart yet, do we?
Not yet. No.
Okay. I forget what we do here.
Okay. So, all right. So here's what we'll do. So we would have. We actually, I think we would go to the chart.
We do. Okay. So let's
Yes.
look up.
Yes.
We'll look up the negative 2. Let's see, negative 2. And it's normal. It's a normal. That's why we're looking at this, right? So, I don't know which one to use, but I'm thinking there has to be, because sometimes the help me solve this will leave out steps because it assumes you know, or it assumes you should.
But let's just do trial and error then.
Okay.
So let's think it's okay. So let's do trial and error. So put in what you think the correct answer is.
Okay. The negative 2. This is the low end score. They're all so kind of close.
Okay, so put the number. So put what you think is correct. See, my biggest thing is we have to do trial and error.
Mm-hmm.
The only way it's ever gonna work.
Okay, I don't know. We'll just pick this here. 0.0228. And I'm gonna write it down so we can try it. 0.0228. I don't know why, but just try it. Um, the table. Well, let's try it. Let's just go back to 7. Wasn't it under 7 on the last problem?
Well, yeah. Well, let's look at what it is consistently. Like, remember, it was point 0.3, and you looked under point 0.3.
Okay,
So
so
let's.
let's so do like kind of corresponding like battleship.
Yeah, let's try it like that.
Okay, so 0.217.
She can't see anything.
Okay. Nope.
Okay, so to find the area of the curve is between two values. Okay, so let's go back and see if we can figure out 0.07. Okay.
Right. Okay, so this, wait a minute. This is the final check. This is asking for the area of the total shaded region. So this should be when we add these two these numbers together, or we subtract.
For the area of the shaded region, you'd have to find the the difference between the 70 and the 120. So you'd subtract remember the high end from the low end.
Okay.
So okay, so the reason it wouldn't make a lot of sense is it would say like 2% of the people between 70, 2% of the people have IQs between 70 and 120. It's going to be significantly larger than that.
Right.
So let's go back to let's go through your steps one more time. And this time, we did trial and error. Okay, so let's see the 0.07. So we know how to do everything except the 0.07, right? Remember, it was talking about 0.07, and we're like, so we did corresponding. So this is the tricky part. So let's go back to that.
To the help me solve this?
Yeah. Okay, so we did that, blah blah blah. We know that's all right. So we did that. It's negative. So it's -2, isn't it? Yeah, -2. Okay. Okay, so all right, now 120. So that would be 20 over 15. Okay, so 1.33.
Okay, so x is 7 is -2. Right, okay, well, okay, we got that.
Okay, so good, okay.
Normal distribution with a mean of 0 and standard. So normal is meaning that it's always going to be a mean of 0 and always a standard deviation of 1.
Yes, so basically what it's saying here is the standard deviation that's being reflected is exactly that. It's not going to go anywhere beyond that. It's a normal standard deviation. So it's between negative, it says -2 and 1.33, because 1.33 is obviously the higher end because it's positive.
Right.
Okay, so let's keep moving forward here. Okay.
Right, so find the area of z-score, begin with a z-score of 2. Okay, we located that. Next, find the value during probabilities below 0. See, this is different than
Okay.
the last one.
Okay.
Is it because this, I don't know. I can't figure out why that is. But
Okay, let's go to continue. We'll click on one time. That's okay, so that's what's weird. You were saying it's under 0, right? Now, why do you...
It just plugs that in. So I don't know where it's figuring that out in here unless you count places over or subtract somewhere from, maybe it's
Or look on the bottom. So you said the standard deviation was 0, right?
And that's the mean.
So, and that's the mean. So the mean would be, like, in this case, I think you said was it 100 for the mean?
Uh-huh.
Okay, so for that, so in this particular situation with 100 being the mean, it says there's a mean of 0 and a standard deviation of 1. So think about it. So it's the standard deviation is going to go either one way or the other one time, but the mean is 0.
Uh-huh.
So this is the part that a lot of students struggle with. The the representation here, and this doesn't do a very good job explaining it, is looking at that standard deviation. I think the other one was the other one like 0.77 or something.
Yeah.
Okay, so the 0, we have to look at that standard deviation, or excuse me, the mean, and that is representative of what we have to really follow. So find the area to the left of the standard deviation. Okay, begin with the z-score of -2 by locating -2 in the left column. Next, find the value of the adjoining row probabilities that is directly below 0.00. So the reason it would be 0.00 is there, if you look with 70, where it's represented for 70 on the lower end, there is nothing to the left of 70. So at 70, it's 0.0.
Okay.
People cannot have an IQ of less than 70 in this situation.
Okay.
So that kind of makes sense?
Yeah, that makes more sense. There's nothing shaded here. There's nothing indicated.
Exactly. So let's go to the looking at the first, or the view of page 1, I think is what it is.
It's negative, yeah.
Okay.
So we're under 0, 2.0, 0.228, 0.0228. Okay.
Okay, so
The area left of Z, that to the left of Z.
okay, so let's see. The area. Okay, so use standard deviation table to find the area to the left of Z. So 1.33. So to the left of Z would be, let's see. Okay, let's click on that. Let's click on that right there.
Sorry, my husband just walked in.
Oh, no
Okay.
problem.
Okay. This the positive one here. So negative or positive 1.33. Here we go. And am I making sense of this negative space here? Is that the corresponding top number is going to be?
So if it's to the left, it's going to be a larger number. So let's see. I just look at it and say, you know what, it's trial and error, because this system that University of Phoenix has sucks, because usually they provide an understanding, like a basis of understanding of why would you choose a particular score. So cumulative area from the left. Okay, so it's not going to be 50%. So if you're looking at 1.33 and you're going left, it's going to be greater than 50%. So let's see.
Oh, dang. And 1.3 and because this is 0.05.
So
It's going to be greater than 50% though?
I'm I'm thinking the IQ would be greater than 50%, because it's basically saying if you're going to the left of that 120, what you're really looking at here is how many people have IQs from 120 to 70. Is it 75?
120 to, I think it's 70.
120 to 70. So something most people will have that. And if you notice with the 1.3 with the -2, it's how many people have that to the left. So it would be 0.
Okay.
It could be a little bit more. So let's see here. And what was that? It was 1.33? So let's go 1.3. It's going to be 90%. So we were right. Let's see here. What is it? Okay, so upon careful estimation, let's say it's going to be because not so it's a difference between 120 in terms of. Let me see something here. Let me see this here.
0. Let's just do this one. 0.9066.
Okay, so let's. Okay.
Because we're still on the help me solve this, so we'll see. I might be able to pull up a tutorial or something on that.
Is there a tutorial that you guys have? Because I'm looking at the methodologies that I've used, and I took some notes on some other people I tutored, and there's different ways to why the Z table is actually used. So let's look at this together.
I'm gonna look up. Let's see, he posted a. Oh wait, oops. Let me go back. Area under the normal curve. That's what we're. Yes.
In this video,
can you hear it?
Yes.
Okay.
To find a standard normal distribution table, I'm going to find probabilities that are of interest. For example, if you are asked to find the probability that Z, and we'll talk about Z in just a second, is less than negative 1.32, using a table, how can we actually find that value? Well, a probability, I want you to think a probability, this thing right here, is simply an area. Right? It's an amount of area. And I showed in a previous video that the total area under a standard normal distribution bell-shaped curve.
Should I be doing this one instead?
So we better get a value. And these values here.
Yeah, click on that one because I'm watching him with this.
I'm thinking this is.
In this short video, I want to show you how to play the game backwards. What I mean by that is this. In a previous video, I showed you that if we were looking for the probability that we had a Z less than, let's shade it to the left, of negative 1.32, we had an area of 0.0934. Right? Again, you can refer back to that previous video if you'd like. But what I mean by playing the game backwards is this. What if this time I give you the probability and I ask you what the corresponding Z is? In other words, if I asked you to find the Z score that corresponds to 0.0250, something like that, for example, do you see that you're given the probability this time? This time you are given, I'm telling you what the area under the curve is, but I'm not telling you what the Z score is. I'm not telling you what the Z number is, and that's what we have to try to find. What's also very important in this problem is the less than symbol that's sitting right here. This is a less than symbol and it's pointing to the left. That is important. So picture-wise, again, really think about the entire picture that's going on here, because that will hopefully really help things and make things clear for you, is this. I have, right, this is a standard normal curve. I am trying to look for a Z score, a Z number, either over here or over here, that if I shade to the left of it, it's going to give me an area of 0.0250. And again, it's shaded to the left because that's a less than symbol. Well, think about that for just a second. If I shade to the left of this thing right here, right, this is going to give me a positive Z number. This one over here is a positive Z number because it's to the right of 0. If I shade to the left of that, boy, that's a lot of area, isn't it? That's a lot of curve. In fact, it's more than half because, again, it's symmetrical, so half of the area is over here on this side of 0, and the other half is sitting over there. Well, that number, 0.0250, is less than half. So I must be looking for a Z score that is negative. not a positive z-score. It's got to be this one. This area makes more sense geometrically here, graphically. Right? It kind of corresponds to this one. It's a number smaller than 0.5, and this shaded area is less than half. It's less than 0.5. So I'm looking for a negative z-score. That's what it's going to be. This number here, when I'm done and I stick it in there, it's going to be a negative something. That I know for sure. Okay, so what I'm going to do is I'm simply going to look on this table, and I keep referring to this table over here because that's what we keep using in our book. I'm going to look over here for a negative z-score. But this time, though, I'm looking in this area. I'm looking in the probability area. This is probability. This is area under the curve shaded to the left. See that? Shaded to the left. So I'm trying to find a number in this area here that corresponds to 0.0250. And if you look at that, you look really hard, you'll see that it comes out to be a negative 1.96. Right, so look at that. Try to find that if you can, but you'll see that it comes out to be this thing right here. Turns out to be a negative 1.96. That is the z-score. I'll stick it in right now. Negative 1.96. There we go. That is the z-score that corresponds to shading to the left. That will give me an area of 0.0250. All right, let's try some other problems like this one. I've got 3 more, and then we'll call it quits in this video. Take a look at these. Take a look at these. We'll take them one at a time. So take a look at this first one here.
But these are easier because they're giving you this on the table and you just pick it out, right?
Well, we're also trying to figure out on the z table, would it be like that 0.5, the 0.00?
Yeah.
That's what he's showing in that bell curve. The negative, it's the reason it's 0.00 is because it can't go anywhere. So that negative, if it was like, if you have a shape like this, right? If you can see my mouse, it's kind of like that.
Mm-hmm.
And what he's saying is, if it's like this, and he's saying like the answer is like right there, there's a line right there.
Yeah.
This is going to be negative right here. And it's going to be really like that 0.00 because nothing can go beyond that. But we're talking about in our bell curve shape like this, that 120 was right over here. So 120 is right over here. That's going to be greater than 50%. As we saw, it's probably going to be something in the 90% range. So let's go back to our table.
We are at the positive. $1.33. Okay.
Okay, so it's positive, right? So what was that? So what was that number that we were looking at? It was
1.3 something.
Okay, so let's see. So I think it's going to be, just go shade to the left. Let's see. Let's put 0.9177 in. I'm thinking that's all the way over here.
To the left.
Or, yeah, I'm thinking, let's try that. That might be too much. Okay. Okay, now let's look at that. Now, why, let's see, why was that? 0.9082. Right there. So it was 0.03, right?
Uh-huh.
Why the hell was it 0.03? So if you think about it, is it 3 normal distribution points away? So let me see. 0.903. Let's see here. Okay. So let's magnify that. Oh, the answer's right there. Okay, so 1.33, right, would equal 0.03. Now let's look at that. The corresponding of 1.33 is, and let me ask you this: what did your teacher teach you on, like, about the numbers that are on top of that z? The z, what's it called?
This chart here, this part.
Yeah, yeah. What did he state those represent?
That's what I'm trying to figure out.
Did he?
Because it's all
So,
online. All of
okay.
this is probability distributions. I think I'm wasting your time.
No.
Because I need to just sit through and watch these videos and.
Well, I mean,
write it.
we're just about done. Here's the thing: each time we speak, I'm, as you know, helping you tutor. I want to help you find the right answer. I don't want to just be like, oh, the answer's this or the answer's that. But the basis that I want you to, like, I want to work with you on is trying to answer those questions that are so important. Like, I know it'd be easy if I was like, well, the reason the Z numbers right on top represent this, represent that. That would be super simple. I'm not trying to be like difficult, but I want you to understand it. So when you're taking the exam, you're like, oh, that makes sense. So really what I'd like to do is, for tomorrow, we talk at 1:30, or we can talk a little bit before 1:30. I'll shoot you a text. First thing I want you to tell me is what do those Z numbers represent?
Okay.
And once we can determine that, then we can talk about how those Z numbers impact what the answer is. Because if you think about it, the progress we made today is understanding how to do the differences, finding the differences, like the 105, was it the 75 minus 105 or 120, whatever it may be, divided by that standard deviation, and then the representation on the actual graph. So it's important to remember in this particular situation, this is kind of it's going to be a process, but I think it's a process that's going to be very effective. So what I'd like you to do is try to tell me what those Z numbers represent. Okay? And I'll talk to you. So once we figure out what those Z numbers represent, then the whole world opens. But remember, we're not going to get all the answers at one time. We focused on getting a good understanding of how to find the area, which is the difference between those two fence posts, like we call them. And now we're going to work on that second factor of the Z numbers. And then we'll have a thorough understanding.
Okay.
Okay? So I'll shoot you a text tomorrow, and then we can just go from there, okay?
All right.
So I don't want you to be disappointed, but again, that way with your exam coming up, you'll be able to ace it once you have a thorough understanding and really understand, the Z numbers and everything.
I feel like I'm too far behind.
No, I don't think you're too far behind at all. What I do think, though, is you didn't have a mastery of the fundamentals. One thing you have to remember is it's more about mastery than memorization. Because when you master something, you're going to have to look at it a lot. And once we master it, my goal for you is for you to tell me, like, no, this is what it represents, and then for me to kind of fill in those blanks. You're not too far behind, but I think you focus more on the memorization and the mastery. And once we kind of shift that perspective and you understand the mastery of it, then you'll have an understanding that it'll become very easy for you. Because like what we did today, did it make sense?
Yeah, a little bit.
Okay.
I still don't understand how to find that top number. I mean, my weekends are spent catching up in this class. I spend the first half of the week trying to figure out how to answer the 2 discussion posts properly. And then I've got a paper due in this class also Sunday, which has to do with what we're learning in here. But since week 3, I feel like I don't have a good grasp on it. And now we're closing up the end of week 4 on Sunday. And then I only have 3 more weeks. And I'm like, how do I, make sure because week 3 I really completely struggled with. And so I don't feel like I have a good grip on those 2 chapters in week 3. And then we have these 2 chapters in week 4. And then week 5 is coming up. So I'm just like, that's a lot to kind of figure out.
One thing to remember here is it's just about balancing that time. So right now, you're not too far behind. You are not too far behind because I think a lot of people are kind of in the same position.
Well, I have there's 2 of these homeworks due, so I have 20 more questions on a whole other thing as well due. Whoops. So, and it's 20 questions, which looks small, but really, they are time consuming. So I just don't know. I don't know how I'm gonna get through these.
Here's the thing: is like you need is like, and these are due. When are these due? On
Sunday.
On Sunday. And when's your paper due?
Sunday. It's half of it. Half of the signature assignment. So we have to do parts 1 and 2. So I've been looking up articles to support my information from other studies, and like that part I feel fine because I'm geared more towards writing papers. I can make sense of it that way. We can create some graphs, which I know I can pull out of StatCrunch and kind of fake it, I guess, for the first half. I might submit it and run it by my professor and say, okay, how crazy am I falling short? If I get a big hit on points on that, I'm not worried about it now, but I have to turn in like a whole 4-part paper. So I add the last 2 parts in week 8 when we do the final quiz. So that gives me a chance to kind of catch up and do a better job on that. So I just feel overwhelmed with the work in this class and then also trying to understand it.
No, and that's totally understandable. I mean, there's absolutely no, I just want you to know that there's no reason that you should feel like you can't do this, because you can. Now, like I said, I don't mind, working with you more than an hour. It's entirely up to you. But one thing is like, unfortunately, I can't like say to you, okay, this is exactly what we're looking at, because when you get to the test, you're not going to know it. You're going to say, oh, crap, what was Ross talking about that one time? It's kind of that struggle. Like I said, tomorrow we can go 1:30 to 3:30. I don't care. It's entirely up to you. But I think it's important that you have somebody who's there you can bounce ideas off of, 1, and 2. Once you kind of have that mastery, having a tutor will allow me to help you fill in the blanks here. So that's the thing, is I want to make sure that you kind of master the material and then explain it to me. Like you said, you be teaching me, and then I can help you fill in the blanks there. Because I think that's an effective way, and that'll actually help you remember. So the thing is it's very important to look at it, I think, in that perspective, because it'll be you'll feel a lot more at ease. Now, at this point, what would you like to work on? Maybe some of your aspects of your paper? Do you want to call it a night right now? Do you want to focus on doing things yourself? I mean, you tell me, whatever you'd like to do.
I think I'm good.
You think? Okay, so do you want to talk tomorrow about 1:30?
Yeah.
Okay. Okay, so let's talk tomorrow about 1:30, and then we can talk about your homework, and then we can talk about your paper as well, so maybe we can get a really good start on that, okay?
Okay, sounds good.
Okay, I'll talk to you later. Okay, bye.
Okay, thanks.
No problem. Bye.
Bye.